The next one is Vigenère cipher. Okay, in this one we will just use a table. Okay, and we will the key stream will be just any specific word. And in this, what happens? Okay, we will just have a complete table of A, B, C, D here. Okay, up to Z, and A, B, C just in the rows. Okay, up to Z. Then, for example, here this is A. We will just start this one with A. Okay, then B, then C, then D. So this one is B, so we will start this with B, then C, then D, then E. Okay, this one is C, so we will start from C, D, E, F, and we'll just keep doing that, and we'll just come back. Then we will just write our plain text and our key stream. Okay, and our key stream, and we will just get these two set of letters. Okay, so we will just take the plain text letter from the columns, and we'll just get the key stream letter from the rows, and we will just find where they collide. Okay, or where they intersect. So the intersection of that will be just the first one. So for T and C, okay, so we have just gotten, for example, V. Clear? So that's it. In the next slide, we will just be doing it in detail. So see, this is a complete table of Vigenère encryption. Okay, and simply how that works. See, our keyword here is code, and our plain text is learn with Sahil. So we just write our code repeatedly, and we just write our text. Okay, so see how it works. The first pair L and C. So that is N. The second one E and O. So E from here up to O. So that is S. The next one A and D. So A and D, that will be D. Then the next one, okay, R and E. So we'll just get R from here up to E. So that is V. Then N and C. So C, N up to C. So that will be P. W and O. Okay. W up to O. So that will be K. I and D. Okay. So I up to D. So again, that will be just L. Then T and E. So T from here and E from here. So that will be X. C and H. H and C. Okay. So we'll just have H from here and C from here. Okay. So H and C, that will be just kind of J. Okay. S and O. So we'll have S up to O. So that is G. Okay. We will have A and D. Okay. So A and D again. So that will be D. H and E. Okay. So H and E. So again, that will be L. Then I and C. Okay. So I and C. So again, we have gotten what? K here. And L and O. So L up to O, which is Z. Okay. So that is how Vigenère cipher works. Okay. So we just changed learn with Sahil to this code, which is just our cipher text. So that is how it works. I hope you have just understood that. Okay. Keep practicing. Okay. Practice with some other plain texts and change them. Okay. Then the next one is the Rail Fence Cipher. Okay. So this is a transposition cipher. Unlike previous methods, the letters themselves do not change. Their order is completely scrambled based on a key. So here we do not change the letters. We just scramble their positions. Okay. Let's see how it works. For example, yeah, learn with Sahil. We will try to just encrypt this. Okay. So see, we just create a table. For example, yeah, here our key is 4. Okay. So here our key is 4. So the key here simply that is the number of rows. How many rows do we have? Then we just write the text in this order. Okay, we will just write it in this order, and one by one we will just simply keep writing them here. Okay, so T. Okay, first we will write this one LT. Then for example, yeah, the second one, so we have EISL. Okay, and we will just keep doing that. Let's see that in more detail. So see, it becomes LT EISL. Okay, then RWAINNH. So how does the decryption work? Okay, so see here, for example, now this time we have gotten this cipher text and we want to just find the plain text. Okay, the original one. So using the Rail Fence Cipher, our key, if it is 4, so we'll just draw this table with 4 rows, and we will just simply have this diagonal lines there. Okay, and one by one we will just write them, the reverse operation of the previous one. Okay, or the encryption. So I'll just write L here. Okay, then T here, then the next one here. Okay, so I S O L, then R, then we have W, then we have A, then we have I, then we have N, and then we have H. Okay, now we will just read it like this. So what we will have our plain text which is learn with Sahil. Okay, so that is how it works. It might be a little bit confusing, but repeat it again. Okay, watch this many times, you will just learn them better and better. So where do we just use encryptions? Okay, so we have gotten active operations in SSL and HTTPs. Okay, secure socket layer and transport layer security TLS are protocols that allow data to be sent securely over internet. Okay, indicated by HTTPS and padlock icon. So for now you just have to understand this much, that yeah, for networking and for sending data through internet we just use them a lot. Okay, and in the network unit, okay, we will just discuss about them further. Okay, so see here, first of all, the browser requests and checks the server's SSL digital certificate to ensure it is trustworthy. Okay, is it just secure or not? When it is secure for the first time, we will just use a symmetric delivery. Okay, to just start a session. So browser uses the server's public key. The server sends a public key to all the browsers. Okay, it shares it publicly to securely encrypt and send a temporary master session key. And the private key is inside web server, so it can just decrypt that back. It can decrypt that back. Okay. Then after that, the rest of the session is just done with symmetric encryption. Okay. Why? Because it is just faster for bulk data transfer. Okay, so that is just how things work. This is a very short description of that. Okay, in the networks unit we will just discuss about them in detail. So let's just have some exam tips and traps. Okay, so first of all, vocabulary matters in the text. Okay, so you cannot write code or secret text or password. Okay, so you must use the words like plain text, ciphertext, or encryption key. So you must know these keywords. Okay, then the asymmetric trap. Asymmetric uses a private key and a password. Okay, so it uses a mathematically linked public key to encrypt and a private key to decrypt. So you have to just know that. Okay, vulnerability justification. If asked why a simple cipher is weak, cite brute force attacks. Okay, so just say that yeah, brute force attacks can just find that. If asked why symmetric encryption alone is risky, then cite the key distribution problem. So talk about them. Okay, so yeah, a simple cipher is weak because hackers can just brute force, can just check many different encryption methods. Okay, and if asked why symmetric encryption alone is risky, then yeah, you have to just talk that yeah, in symmetric encryption the key is shared publicly. Okay, so that creates a problem. Let's just talk more about terminologies. Okay, you have to just know these terminologies. Word bank, for example, asymmetric, certificate, parallel key, protected, serial key, and symmetric. Okay, so see, plain text is encrypted into cipher text using a public key. The encrypted data is then transmitted from the sender to the receiver, and the encrypted data is then decrypted using a private key. So you have to know these keywords, and you have to know how they are used. So task 1, okay, give the result of decrypting the ciphertext PZFBKZB using the Caesar cipher with a key of left 3. So this is the ciphertext. So if that is left 3, it means we have to just decrypt that. So for decryption, we will just use right key. Okay. So for the solution of this one, first of all, identify the operation. So we are decrypting. We have the ciphertext. We want to find the plain text. So we are decrypting. So we must use reverse algorithm. Then reverse the shift. Since it was encrypted with left 3, we decrypt by moving right 3. So apply the shift, for example, P, okay, applying right 3 to that, okay, so P will change to S, Z will change to C. Why? Because just we wrap around, okay. F will change to I. So apply this, okay. The final answer has to be science. So decrypt this and see if your final result becomes science. Clear? To learn more. If your answer was correct, so you have learned. If not, then you have to just watch the video once again. The objective, it means why do we encrypt? Okay, encryption makes intercepted data meaningless to unauthorized users, so ensuring privacy, trust, and legal compliance. Clear? So if somebody gets the data, they will not be able to read it. The framework, okay, so we have gotten symmetric, one shared key. It is fast but suffers from distribution risk. So the shared key is just distributed. Then asymmetric, two linked keys, public to lock and private to unlock. Public key for encryption and private for decryption. Okay, so this solves the distribution problem, but computationally it is heavier. It is more complicated. And the algorithms ranging from simple historical substitution, Pigpen, Caesar, Vigenere, and transposition, Rail Fence, to modern hybrid secure protocols. Okay, so we have just gotten different algorithms. So that's all about encryption for IGCSE. Okay, I hope you have understood. It is a little bit confusing. Okay, so you might need to just watch the video 2 times or 3 times, but I can assure you this is just the complete data you need for your IGCSE exam. Wish you all the best, good luck, and goodbye.